Hello students, this is part 11 and last part of chapter motion class 9th physics. In our previous part we have learned about the various terms related to motion and also solved the numericals based on uniform circular motion and graphs. In this part again we will solve some additional numericals based on the whole chapter motion, but before that we will solve that numericals that I have given you for practice in the last part. I hope you have solved them, but somehow if you are not able to solve them, then here is the solution. So basically these are the three questions for practice that I have given you in last class. So let me solve each of these questions one by one. So our first question is the velocity time graph as shown in figure. As you can see here, this figure shows the velocity time graph for motion of a cyclist. And with the help of this graph, we have to find the acceleration of the cyclist, the velocity of the cyclist, and distance covered by cyclist in 15 seconds. So the graph given is the velocity time graph, and from this graph it is clear that the graph is straight line parallel to time axis. So if the velocity time graph is a straight line parallel to time axis, it means that the object is moving with constant velocity. Or we can say that at some instant of time, that is at 10 seconds, the object has a certain velocity of 20 meter per second. And after 10 seconds, that is 20 seconds, again the object has the same velocity of 20 meter per second. It means that if we want to find the change in velocity, then the change in velocity is 20 meter per second minus 20 meter per second. Then it comes out to be 0. So if the change in velocity is 0, then we can say that acceleration is 0, because we know that acceleration is the rate of change of velocity. Hence we can write, as Vt graph is a straight line parallel to time axis, the motion is uniform motion along a straight line, and hence acceleration is 0. Now let us move to next part. We have to find the velocity of the cyclist. So from this graph it is clear that at every instant of time the velocity is same for the cyclist, that is 20 meter per second, because the cyclist is moving with a constant velocity of 20 meter per second. Hence we can write, from the graph the constant velocity of the cyclist v is equals to 20 meter per second. Now in third part of this question we have to find the distance covered by the cyclist in 15 seconds. As we have to determine the distance covered by cyclist in 15 seconds, so we draw a perpendicular from the point B to time axis corresponding to time t is equals to 15 seconds. So BC is the perpendicular which meets the time axis at 15 seconds. Again students, you know that the area under the graph of velocity time gives the magnitude of displacement or the total distance covered by an object. So from this graph we can find the distance covered by the cyclist in 15 seconds is equals to area of the rectangle OABC, and area of rectangle OABC can be written as OA into OC. Now again you know the magnitude of OA is 20 meter per second and OC is 15 seconds. So we just multiply 20 meter per second into 15 seconds. It comes out to be 300 meter. Hence we can say that the distance covered by cyclist in 15 seconds is equals to 300 meter. Now what was our next question? Our next question was that, can an object have a constant speed and still be accelerating? Give an example. Now students, you know that acceleration is the rate of change of velocity, and velocity is a vector quantity, meaning thereby it has both magnitude, which we call speed, and also direction. So velocity can be changed if the speed is changing, or if the direction is changing, or both speed as well as direction is changing. So let me recall you an example, that is uniform circular motion. In uniform circular motion we have learned that the object is moving with constant speed, but its direction of motion is changes continuously. As the direction of motion is changing, then we can say that the velocity is changing, and if velocity is changing, then the object has an acceleration. So we can say that yes, uniform circular motion is an example in which speed is constant but also there is a acceleration. Now students, our third problem was that a man moves a distance of 3 km towards east then 2 km towards north, and then 3.5 km towards east. Find the distance covered by the person and the displacement of his motion. Now students, you are well aware of these directions. This is east direction, this is north direction, this is west direction, and this is south direction. So we will use these directions to draw the position of the person. So let us draw distance of 3 km towards east. So this is the distance of 3 km towards east. Now the person reaches at this point. After reaching at this point, again the person travels a distance of 2 km towards north. So let us draw. This is the 2 km towards north. Now the person has reached at this point, and from this point he traveled a distance of 3.5 km towards east. So let us draw. Now this is the 3.5 km towards east. So let us do some naming. Now it is clear that A is the initial position of the person and D is the final position of the person. So let us join these points. Again we can say that in order to reach from the point A to point D, that is from initial position to final position, the person has taken the path AB, BC and CD. So we can say the distance traveled by the person in this journey is equals to sum of AB plus BC plus CD, which can be written as 3 plus 2 plus 3.5 km, because AB is equals to 3 km, BC is equals to 2 km and CD is equals to 3.5 km. So after adding these values we have 8.5 km. So we can say that the distance covered by the person in this journey is equals to 8.5 km. Now let us try to find the displacement in this journey. So again from this diagram it is clear that A is the initial position and D is the final position, and we know that the shortest line joining the initial to final position gives the magnitude of displacement. So AD can be calculated with the help of the triangle AED, and AED is a right angle triangle. So net displacement, which is equals to AD, can be written as square root of AE square, that is base square, plus perpendicular square, that is ED square. Again it can be written as AB plus CD whole square plus BC square within the square root. Because we know that AE is equals to, here you can see that AE is equals to AB plus BE and BE is equals to CD. So AE can be written as AB plus CD. In the same way, BC is equals to ED. So ED can be written as BC. Hence, we have this formula. Now let us put the values. So after putting values, we have square root of 6.5 square plus 2 square, because AB is equals to 3 and CD is equals to 3.5. So 3 plus 3.5 comes out to be 6.5 and BC is equals to 2. It can again be written as square root of 42.25 plus 4, which comes out to be square root of 46.25, which is equals to 6.8 kilometer. So we can say that the displacement of his motion is equals to 6.8 kilometer. Now students, our next problem is that a train traveling from rest picks up the speed of 10 meter per second in 100 seconds. It continues to move at the same speed for the next 250 seconds. It is then brought to rest in the next 50 seconds. Plot a speed time graph for the entire motion of the train. Find also acceleration of the train while accelerating, retardation of the train while retarding, and total distance covered by the train. As you know, in a speed time graph, we represent time along the x-axis. So you can see here, the time is represented along x-axis with the equal interval of 100 seconds, and speed is represented along y-axis with the equal interval of 5 meter per second. Again from this problem, it is clear that the train starting from rest and after undergoing uniform acceleration for the next 100 seconds, it attains a velocity of 10 meter per second. So the graph for the 100 second can be represented as a straight line passing through origin, as you can see here. Now after that, it is given that for the next 250 seconds, the train is moving with the same speed, that is 10 meter per second. It means we can say that for the next, that is from 100 to 350 seconds, the train is moving with a constant speed of 10 meter per second. So the graph for the next 250 seconds can be represented by the straight line BC, as you can see here. And after that, the train is brought to rest in the next 50 seconds. It means from the time 350 to 400 seconds, the train is brought to rest with uniform retardation. So we can represent the graph as the straight line CD, which is sloping downwards. So this is the required speed time graph for the given problem. For our convenience, we will draw a perpendicular line from the point B to time axis, which cuts the time axis at the point M. And again we draw a perpendicular from the point C to time axis, which cuts the time axis at the point N. Now we have to calculate the acceleration of the train while accelerating. So from this graph it is clear that the straight line AB shows the accelerated motion. So acceleration of the train while accelerating can be calculated with the help of the triangle ABM. So we can write acceleration is equals to Bm upon Am. Again we have the value of Bm as 10 meter per second and Am is equals to 100 second. So after putting this value we have 10 meter per second divided by 100 second, which comes out to be 0.1 meter per second square. Hence we can say that acceleration of the train while accelerating is equals to 0.1 meter per second square. Now let us move to next part. In next part we have to calculate the retardation of the train while retarding. Again from this graph it is clear that the region CD shows the retardation. So retardation can be calculated with the help of the triangle C and D. And we can write retardation is given by Cn upon Nd. Again we have the value of Cn given as 10 meter per second and Nd is equals to 400 second minus 350 second, that is 50 second. So after putting the values, that is 10 meter per second divided by 50 second, it comes out to be 0.2 meter per second square. Hence we can say that the retardation of the train while retarding is 0.2 meter per second square. Again students, you know that area under speed time graph gives the magnitude of displacement or the total distance covered by the object. It means that the total distance covered by train is equals to area of the trapezium ABCD. Hence we can write total distance covered by the train S is equals to area of trapezium ABCD. And you know that area of trapezium is equals to half of sum of parallel sides into perpendicular distance between them. So here in this trapezium ABCD, you can see that AD and BC are two parallel sides and BM is the perpendicular distance between them. So we can write area of trapezium as half of AD plus BC into BM. Now putting the values, we have half of 400 plus 250 into BM, which is equals to 10. Hence it comes out to be 3250 meter. It means the total distance covered by the train is 3250 meter. See problem 5. Which of the following distance time graph is possible? Give reason for your answer. So let us study this distance time graph and find out whether these are possible or not. So see graph 1. So graph 1 is the distance time graph in which time is represented along x-axis and distance is represented along y-axis. Now from this graph it is clear that the graph is a straight line which is parallel to distance axis. It means that distance is continuously changing, but there is no change in time. So students, is it possible that without changing time, distance can be changed? No, it is not possible. Hence, we can say that this graph is not possible because distance covered cannot change without change in time. Now let us see the next graph. The next graph is also a distance time graph in which time is represented along x-axis and distance is represented along y-axis. Now let us see, up to this extreme point the distance is increasing with increase in time, but onwards this upmost point the distance goes on decreasing. As you can see from the nature of graph, the distance goes on decreasing. So students, is it possible that distance will decrease with increase in time? No, it is not possible. Hence again we can say that this graph is not possible because distance covered cannot decrease with increase of time. Now move towards our next problem. So problem 6 is that the velocity time graph of cars A and B, which start from same place and move along the straight road in the same direction as shown in the figure. As you can see here, this is the graph for the two cars A and B. Now we have to calculate the acceleration of car A between 0 and 8 second, the acceleration of car B between 2 second and 4 second, the points of time at which both the cars have same velocity, which of the two cars is ahead after 8 seconds and by how much. So let us solve each part one by one. In first part we have to calculate the acceleration of car A between 0 and 8 seconds. So from this given velocity time graph, it is clear that the line OA represents the graph for the car A. And we also know that slope of the velocity time graph gives us the acceleration. But for determining slope we need a triangle. And we have to determine the acceleration of car A between 0 and 8 seconds. So we need such a triangle having base from 0 to 8 seconds. So from this graph you can see that OAB is such a triangle having base from 0 to 8 seconds. So we can take help of this triangle OAB. So from this triangle OAB we can write acceleration is given by AB upon OB. Again you can see that the value of AB is equals to 80 meter per second and value of OB is equals to 8 second. So by putting this value, AB is equals to 80 meter per second divided by 8 second, it comes out to be 10 meter per second square. Hence we can say that the acceleration of car A between 0 and 8 second is 10 meter per second square. Now in next part we have to calculate the acceleration of car B between 2 second and 4 second. Similarly, we have to find such a triangle which have a base from 2 second to 4 second. That's why we construct a line XY which is parallel to time axis. So from this triangle XYD, it is clear that this is such a triangle having base from 2 second to 4 second. So taking the help of this triangle XYD, we can write acceleration is equals to x dy upon xy. Again the value of dy can be written as velocity at the point D minus velocity at the point Y. You can see that velocity at the point D is 60 meter per second and velocity at the point Y is 20 meter per second. So dy can be written as 60 minus 20 and xy can be written as time corresponding to point Y, that is 4, minus time corresponding to point X, that is 2. Hence we can write dy is equals to 60 minus 20 meter per second and xy is equals to 4 minus 2 second, which comes out to be 40 meter per second divided by 2 second and it is equals to 20 meter per second. Hence we can say that the acceleration of car B between 2 second and 4 second is equals to 20 meter per second square. In this part it is asking the points of time at which both the cars have same velocity. So basically what we have to do, we have to find the point of intersection of the graph of two cars because only at the point of intersection the two cars have the same velocity. So let us find out. As we move on the time axis, we see that at time t is equals to 2 second, the two graphs intersect each other, and again at time t is equals to 6 second, these graphs intersect each other. Hence we can say that since the graph for car A and car B intersect at 2 points corresponding to 2 second and 6 second, hence they have same velocity at these points. Now in last part we have to find which of the two cars is ahead after 8 second and by how much. So for determining this we have to find the total distance covered by both the cars after 8 second, and we know that distance covered by an object is equals to area under the velocity time graph. So from this graph it is clear that total distance covered by the car A is after 8 seconds is equals to area of the triangle OAB. Hence we can write distance covered by car A after 8 seconds is equals to area of triangle OAB, and OAB is a right angle triangle having area equals to half base into height, that is half OB as base and height is AB. So we can write half OB into AB. Again OB is equals to 8 second and AB is equals to 80 meter per second. So we can write half into 8 second into 80 meter per second. It comes out to be 320 meter. It means that distance covered by the car A after 8 second is 320 meter. Now let us find out the distance covered by the car B after 8 second. So we have to find the distance covered by car B after 8 second. So that is given by the area of the trapezium CDEB. Hence we can write distance covered by car B after 8 seconds is equals to area of trapezium CDEB. Again in the trapezium CDEB, you can see that CB and DE are two parallel sides and BE is the perpendicular distance between them. So we can write area of trapezium CDEB is equals to half of sum of parallel sides, that is DE plus CB, into perpendicular distance between them, that is EB. Now we know the value of DE is equals to 4 second and CB is equals to 7 second and EB is equals to 60 meter per second. So after putting this value we have 330 meter. So we can say that distance covered by car B after 8 second is 330 meter. But we have seen that distance covered by car A after 8 second is 320 meter. So we can say that car B is ahead of car A by 330 minus 320, that is 10 meter. Okay students, now the remaining questions you have to solve by yourself, and if there is any problem then let me know in the comment section. And from our next class we will start our second chapter, force and laws of motion. Thank you.